Good afternoon, all. So, in previous class, what we were seeing, we have seen about various clustering types and how it is works, right? And in the end, we have seen about hierarchical clustering. So, in our hierarchical clustering, also we have seen two types. So, what are they? So, we have seen agglomerative clustering and then diversity based clustering, right? So, in today's class, we are going to see this hierarchical clustering example mean algorithm with one example. Okay, so let me share my screen. Okay, so we are going to see about the class customer spent analysis using the hierarchical clustering. So previously we have seen one customer spent analysis by using what algorithm? K-means, right? Again, that is also an unsupervised learning. But what is the difference between this algorithm or this data set and that data set is in the K means we have used only two columns. One column we have given for income and second column we gave it for expense or spent. Okay, and we have passed it to into our algorithm and we try to create a pattern. Okay, how many clusters or how many K mean value we can able to create, that we try to find. So here we are going to have more than two columns. Okay, so that also I will just show it to you. So here if you see means we are having a column name like customer ID, gender, okay, age, and then annual income. Finally, spending score, how much they have spent. So it is given in the form of score. So here what is not necessary is customer ID may not be needed. Okay, so we have seen one example, right? In clustering method, we can separate by various categories. So if I am splitting with gender category means I can create two cluster. Okay, age means different age category. I can create some different cluster, and then based on the annual income as an average from this to this range, how much the person is getting. Based on that average, we can create a cluster, or based on the spending score also we can create various cluster types. Okay, so let us see these steps and then we will directly go into the program part. Okay, again this is going to be a short program only so we can see it better. So first, what is the problem application? So what we are going to find? Okay, so we are going to group the data on basis of what? Categorizing the information based on amount spent. Okay, let me zoom it a little bit. Okay, so as a first step, we know why. See, previously in supervised learning and all, I have written like to predict, but here no prediction is happening, only grouping. Just nothing but cluster creation only happening here in unsupervised learning. So that is why I mentioned it as to group. Okay, so we are going to group based on the amount spent. Then collected data set. So just now only I have showed you the data set. In our data set, we are having a customer ID, gender, age, annual income, and then spending score we add. Okay. Then load and summarize the data. So we know we use the panda method to load the data set, and we will try to find the head shape of our data set. Okay, to know how many rows and how many rows and columns are there, we can use dataset dot shape, and using the shed method we can see a short summary of the dataset. First five columns we can able to see. Okay, then in the fourth step what we will do is we can perform label encoding. Okay, or we can use the mapping method also. So both we can use anyone if we want means we can use. So when we will go for label encoding, here I have mentioned like label encoding, but if you have seen my data set, hope my data set is also visible. We have already performed from pre-processing, right? In the pre-processing, what we will do, we will try to convert all the categorical data into numerical form. Here, what is the categorical data column we are having? The gender column. So previous example, same type of example we got, right? Male, female category was there. So for that, what we used mapping method, right? We when male means we will say 0, female means we will say 1. So like that, we used mapping method. So that also you can use because this is simple split up only. Suppose you are having a category of 10, 20 categories there. Okay, that time manually creating, one means apple, two means orange, like that you are manually creating means it will take some time, right? So in that case we can go for this label encoding method. So what this label encoding will do is it will take only the unique values, and for each value it will create one unique number. Okay, so that one means it represents the product 1, product 2, like that we can understand. So that is the purpose of label encoding. Yes, but uh, see, in mapping, we have to manually give what is the old value and new value. But in label encoding, we don't need to give manually. We have to specify the column. What that particular function will do is it will take the unique values from that particular column, and then it will assign numbers to those column. Okay, that is the difference between label encoding and normal mapping method. Okay, very two three categories there means manually we can do, but more categories there we want to perform faster means we can go for label encoding method. So to perform this label encoding, it is directly available in sklearn dot pre-processing. Okay, we can use sklearn dot pre-processing method to label those category. Okay, otherwise here I am just going to use the mapping method. Why? Because we already know, right? How to use the mapping method and all. Okay, then just a minute. Okay. Mm. So here, same male means 1, female means 0. Here we are taking. Okay, to label the gender text data to a numeric value. Okay, then only we can pass it into our algorithm. Okay, for training purpose as well as testing. Then what will be the next step? Fifth step is going to be the algorithm, the actual algorithm. So hierarchical clustering, how it will work, and this diagram also I have explained in that day itself, right? This type of diagram we call it as dendrogram diagram, and how it is finding the distances based on the Euclidean distance. The formula, how to apply the formula, everything we have seen. Okay, if you have not watched the previous class video means watch it so that you can understand. Okay. Hmm. No, no. Agglomerate means it will perform from top, bottom to top. Diversity means it will perform from top to bottom. Okay. Here I am going to use only agglomerative method only. Okay. So these are the various methods. Okay. So first let us see the definition. So in a data mining and the statistics, hierarchical clustering is a method of cluster analysis which seeks to build a hierarchy of cluster. Okay, in K means it is not creating a hierarchy of cluster. It will create separate individual cluster. But here it will try to create a hierarchy. Okay, entire data set into a bigger cluster. So inside that subcategories of cluster will be created based on the distance. How close one point to the another point is there, it will become one cluster. Okay, and how far it is, it will become a new cluster. Okay, and various methods is like computed distance matrix. So why it is given like step like matrix is, So if I want to find B to A, okay, that okay, PPT also I have showed you, right? Whatever you are getting in the lower triangle, same value only you will get in the upper triangle also. That is why here they haven't mentioned the upper triangle part. Okay, same value will become 0. Okay, remaining will going to be same value as the lower triangle. Okay, so that's why it is looking like a like step like values we have mentioned. From this is nothing but a distance from point B to A. What is the distance it will be having? Okay, and point C to A, point B to A. Once we have found the lowest value, we will combine that 2 points. So in this example itself, if I take the lowest point means I will take 10, right? There is nothing lower than 10. So if it is 10 means what I will say, E and F will be one cluster. Then keeping that E and F as one cluster, again we will perform. Again and again we will perform until we get last one cluster which contains all the points. Okay, this is nothing but the distance matrix. Okay, so this distance matrix also how to calculate and all we have seen, and how to combine the cluster, creating cluster, everything we have seen. And so using the equivalent distance, we will perform this distance method. So distance between two cluster has been computed based on the length of the straight line drawn from one cluster to the another cluster. So any point from one point to another point, if I am drawing a straight line means, then it means I am using the equivalent distance method. If I go for Manhattan method means what will happen? I have to follow some proper procedure. Okay, and formula also varies. So in Manhattan, we will not use the square of like that. We will not use directly. We go for absolute of x2 minus x1 plus y2 minus y1. We will go. Whereas when I go for the Euclidean distance method, I have to give square root of y2 minus y1 the whole square plus y2 minus y1 the whole square. Okay. Then we have seen linkage criteria. So what are the here, when it come to the agglomerative and methodological, nearest cluster we want to find means how we can create a step value. See, let me draw it and show it to you. Otherwise, I will. Mm, just a minute. So hope my PPT is also visible now. See, between any 2 points, okay, from one orange to another point, how you can create find a Manhattan distance, which will be easier to find. Euclid is only easier to find, right? Then only closest value we will find, and then we can make it as a cluster. When we go for Manhattan method is, suppose you are having some proper pattern is there. Okay, like I have told one example, right? Google Maps and all is there. Okay, and you are putting on source and destination, and in that time we cannot directly point, okay, this is stores means directly I cannot draw a line to the destination. I have to draw a line based on the road, exact road, like that we have to create, right? So there and all it has to calculate the Manhattan distance method. Whereas here for creating the cluster, I cannot go for the Manhattan. Okay, two methods are there. If I'm going for Manhattan means it will use that algorithm to find the closest distance by applying it in the formula. See, anyways, from current position to the next position. Otherwise, here I will make it as full screen. See, current position to new position is there. Okay, for example, this distance is 1 centimeter. Okay, for example, I'm saying, and we know that what is the point x. Okay, this is assume that this is point x and this is point y. We know what is the x value, or I will keep it as point 1, point 2. Okay, so what is the point 1 value? Here x is going to be there, right? Here assume that 5 is there, and here assume that is 3 is there. Okay, so if I ask what is the point value of this one, what you will say? 5 comma 3, right? When I ask for point 2, obviously it is going to be more than 5. Okay, for assumption purpose I'm just saying more than 5 means assume that it is 6, and here it is like little bit upper than the third, so I can say 3.5, just for our understanding. Okay, what I have to do is, if I'm using equidistance means I'm going to put this value in my equidistance formula. If I'm using Manhattan means I'm going to put same values in the Manhattan formula. That is the difference. In the parameters when we are passing, we have to specify whether in KNN also we use, right, whether you are going to use equidistance or Manhattan or Minkowski method. In we have given Minkowski. Inside the Minkowski we had one means equilibrium, two means Manhattan. Like that we had option. Here also you can use the parameter and choose your distance method. Okay, it is totally up to you. For one time you can run with equivalent distance and check the performance. Okay, it is giving 90% accuracy. Next time you are checking the same data set with the Manhattan distance. If it is giving more accuracy means you can stick with the Manhattan method. Okay, it is all about hyper tuning. You will change the parameters and you will tune your algorithm. In which particular point it is giving a good accuracy, we will fix to that particular point. Okay, it is like trial and error. Whatever parameter is there and whatever options are there, we will try to explore. At one certain point, it will become more accuracy. It will give more accuracy. Then we have to fix. Okay, for this data set, this algorithm, this parameter is working better when compared to others. Like that, we will come to a conclusion. Okay. Okay, let me share once again. Then that is where we go for the another one parameter called linkage criteria. This linkage criteria also we have seen three types. What are they? We have seen shortest one and then longest one and then average one. Remember, shortest we will give like a complete criteria, don't remember. It's okay. Single linkage means closest to value we will find from one cluster to another cluster, which 2 points are very closer. That value alone we will take. If I am taking the largest distance, okay, largest distance means from one cluster which point is very large, and then in the another cluster which point is very large. So what is the distance between these two clusters? If I am finding that means I will call that linkage as complete linkage. Okay. Whereas if I am finding the average of each point, okay, from cluster 1, I am taking an average of all the other clusters in the cluster 2 means, then I will call it as what? Average clustering method. Otherwise, I will show in the PPT also. See, this is what I am trying to say. Linkage, I mean, single linkage means closest to point, whereas complete linkage means far distance, okay, longest distance between 2 point in each cluster. Whereas when I go for the average linkage means each point it will check with all the other cluster present, I mean all the other points present in the another cluster. Okay, then so by default we are having another one also. We call it as ward. Okay, this method workouts which observation to group based on the reduction the sum of square distance. That also we have seen in k means. Remember, in k means we use WCSS, within cluster sum of squares. So that method it will do to find the average observation in a cluster. Okay, default it will be word. If you want means you can change it into average or complete or single linkage based on your need. Okay, then we will see different types. Okay, we have seen like distance matrix we have seen. For that we are using Euclidean distance. Then we are having linkage criteria. So three different linkage criteria is there. and by default we use another linkage criteria. Again, in default also it uses average method only. Okay, and different types. So in different types only we have seen agglomerative means it will be like a bottom to top approach. Bottom to top means each cluster will consider as a separate cluster, and then nearest value will be grouped together. Whereas when I come to the diversive hierarchical clustering means first every point it will group into a single cluster, then one by one it will start splitting them into small cluster, and finally each point will become a individual cluster. Okay, so that is what we call it as diversive hierarchical clustering. Okay, see in the image itself if you are drawing means it is an clustering method, and if I am converting into a step value like hierarchical method, if I am converting means this I am calling it as a dendrogram diagram. Okay, proper structure you are giving, right? So root is there. Okay, nothing will be in the root. So from that root, two subcategory has been splitted. From these two subcategories again another two subcategory, another subcategory, until each point become an individual cluster. This will be continued. Okay, so let us see the steps. Up to here it is clear, right? So we have seen the algorithm like definition, method. Okay, in the method, distance matrix and linkage criteria types we have seen. Now we are going to see about the steps. So in the first step, what we will do? We will identify the two clusters that are very closest. Then we will merge the two most similar clusters. Okay, where we will do this? In the agglomerative method, we will do this. Okay, then once we have performed this operation repeatedly until it complete the process for all the iteration, then we will go for the data visualization. Okay, if you want means you can visualize it the data set by drawing the dendrogram diagram. Okay, what we will do? We will use the scattering plot. Okay, we can use the scatter plot to point all the values. By seeing the plot itself, we can get some understanding. Okay, this many clusters can be created from this data set, like that you can understand. Okay, so different points, then final output. Like similar like this, you are getting some output. Okay, then we have to fit in the model to the clustering algorithm. So here fitting will happen. And another one thing, here we will not do the train and split. That step we will not do. And another thing we will not do is x and y value we will not split. Everything will taken as only single x value. Okay, that is the difference between like normal supervised learning and unsupervised learning. Okay, very easier to perform. Then this is how my final output is going to be there. If I'm taking 5 means like 5 different color cluster is there. See, center point it is coming like red, and then we are having blue, yellow, green, violet color is there. So like that, see, by seeing itself I can say, right, this blue color and all it can be one cluster, this orange or maybe yellow color can be another cluster, violet and all can be one cluster, green, so whichever is in the center, we can call it as red color cluster. Okay. Then visualizing the clustered result. So hope it is clear for you all. So let us directly see the program part. Okay. I think my screen. Okay. Hope my screen is visible to you all. Okay. So first step, we all know we have to import the basic library. Here, the basic library we are having is pandas and matplotlib. So I'm just going to import here itself. Okay, pandas as PD. Okay. Then importing the data set. So data set pd.read underscore csv. So my file name is I think okay, my file name itself dataset.csv only. So that also imported. So I have to summarize the data set like I can simply give dataset.shape. So totally we are having 200 rows and then 5 column. Okay. And what is the method? What is the method we will use to find what are all the columns present in our data set? So simply we can use dataset dot columns, right? So this also will give us what are all the columns are actually present in our data set. Okay. Here, which is more important among this column, which is more important is this annual income and then the spending score, because our problem is that only, right? Customer spending analysis only we are going to do. So customer based on the income and spend only we can compare. So if I want to create an graph also, we we have to give only x and y axis. So what is going to be my x? The annual income is going to be my x, and then the spending core is going to be my y. Okay. So if I want to plot directly by using the without using matplotlib also we can plot by using the pandas method. So for that what we have to do is, this is a new syntax I'm saying. Okay, so data set dot plot I'm giving. Okay, previously and all, but what we will use the matplotlib method plt dot plot or plt dot scatter we use, but here directly I'm giving data set dot plot dot, and what scattering method you are going to use is, sorry, what graph method you are going to use is scatter method. So scatter, and I can directly specify my x and y value. So x is going to be my annual income. Okay, I'm just copy pasting it here to avoid spelling mistake and spaces. So this is going to be my x and comma, this is my y value. Okay, let me run and check. See, this is my plotted value. So whatever you have seen in the mind map, before performing the hierarchical clustering, all points is going to have the same colors because I didn't specify any different color, right? So from here itself, we can assume the pattern. Okay, five cluster can be created out of this. We can give more also. If we are giving more means these and all we can call it as outlier values. See here you are seeing, right, few values, because it is very far from the actual pattern, right? If you are giving more value means it can be created as a separate cluster also, possibility is there. So apart from that, if you are if you want to create a cluster means this entire area I can make it as one cluster, two, three, four, five, like that. Five different cluster you can create. And previous example in k means for creating four cluster, we have created four cluster I guess. I don't remember. So what we have given, like low income, low spent, high income, high spent, like that I have created various category. Here also you can separate. How we can separate is, this portion is there, right? 0 to 40, and then here 20, I mean 0 to 40. This portion alone we can take it as low income and then low spent people. Okay. Whereas in the same range, if you are seeing in the top, they have spent score is very high, whereas the income rate is very low. So these category people, what we can say, low income but high spent people. Okay, like that we can say. In the middle, we are having some cluster, right? So what we can call these type of category people? So medium income and medium spent, maybe we can say. And then here after 60 if you are coming means more salary getting people are there. So after getting more salary also, there are some people who spent very less. So high income, less spent category people are there. Same high income and high spent category people also is there. Okay, like this we can create various categories. Then label encoding. So again, label encoding and mapping are both are same. Okay, just performance alone is going to change. I will just type the code for label encoding, but if you want me, you can use interchangeably. Okay, so this is the going to be the syntax. So from sklearn, import the pre-processing. Okay, so pre-processing we have to import, and then I'm going to create a label encoding, right? So for that, I'm creating an object. Okay, this is nothing but a class. So for that, I'm going to create a object. So I will give object name as label underscore encoder is equal to pre-processing. Okay, inside the pre-processing, we are having label encoder method. So label encoder method. Okay, so this will create an object. Then, sorry, then I have to specify for which column I have to perform the label encoding. Correct. So I have to give label underscore encoder dot fit underscore transform. So this is what you have to give, fit underscore transform, and you have to specify in the data set which column you are going to transform. I'm going to transform the gender column. Okay, so this will return a new value. Okay, the encoded value, new value only it will return. As a next step, I want to update it into my actual data set. As of now, I am not yet updated. So let me run and check what I'm getting it as output. Then I will change it. See, whatever we used to do in the mapping method, we manually has to give male means 0, female means 1. Instead of that, it automatically detected the category and then it assigned the value for those categories. Okay, to know that for which it has assigned 1 and 0, in the summarize section itself, if you have given, for example, another one cell I'm just creating, and then I'm giving dataset dot head. So 10 rows I'm checking means, see, first two is having male as a gender. So male has been taken as 1 in this case and female has been taken as 0. Okay, using the label encoding method. Okay, so manually if you are giving means we can go for mapping method also. So that syntax also I will write, but I will comment it. Okay, I will not run it. Here also I have not yet completed. It has returned a new array only. Okay, still if I go and check my actual data set. So if I go and check my data set dot head, it is still going to remain as male, male, female only because I have not yet updated. So for updating, what I have to do? I have to store that in the same value. So data set, okay, uh, we have to give gender. So change the gender value to label encoding dot fit transform method. So it will convert and it will store in the same location. So now if I go and check my label, I mean dataset dot head, see all the head has been converted to one. Sorry, all the male has been converted to one and all the female has been converted to zero. Okay. Ah, once in zero, no, no. If you are having more category means zero, 1, 2, 3 like that it will. Ah, in numbers only it will create. Okay, category starts from 0, 0, 1, 2, 3 like that only it will create. Okay. So if I go for mapping means simple. Right now map will not work. Why? Because I have already converted my actual data set. So I'm just giving the syntax. So when you are running this program means you have to give either one of it. Okay, either you have to go for label encoding or you have to go for the mapping method. So data set gender, okay, dot map, okay. So and you have to give it as in the form of dictionary male. Okay, so previous example we got male equal to 1. So I'm giving the same example. Male is equal to 1, female. Okay, that also should be in quotes. And here the key is nothing but the existing value and after colon whatever you are giving is going to be the updated value. So for female, I have to give it as 0. To keep it as integer number, I have to convert it into as type as integer. Okay, this and all we don't need to do in the label encoding because by default it will be stored in automatically in integer. So no problem. Okay, so I'm just commenting it out. So if you are using this means you can check whether it has been converted or not by using the dataset dot head method. Just a minute. Okay. Then as a next step, I have to find okay dendrogram diagram no need I think. So by seeing the diagram itself, we have little bit come to a conclusion, right? We can create a 5 cluster out of this data set. So keeping this as a value, I'm going to find 5 cluster. I'm going to create 5 cluster out of this particular data set. Okay. And if you want to find what is the best n value means, we already know, right? How we will find the best k value. Same concept, you have to use it here also. Okay, currently I'm not using. Maybe if you are practicing means same syntax, like whatever you use it for finding the optimized k value in a k means, same you are going to pass it here. But instead of k means algorithm, we will use hierarchical clustering algorithm. That alone is going to change. Instead of that value alone changes. So, okay, we have to pass from 1 to 10 if you are passing means, which is showing the minimum value that we can take. So here it is very clear. Data set is very clear for creating various maps. If you want means for this also you can give 3, 2 like that. If you are giving means accordingly it will split. If I give 3, what will going to happen is left hand portion it will take like for 20 to 40 is there, right. Entirely it will take it as one cluster and from 40 to 60 okay or 70 we can say that portion can be taken as another one cluster and remaining portion all will it can be taken as third cluster. So all possibilities are there. Okay, otherwise to make you understand first I will give it with 3, 4 then 5 I am giving means how it is finding the output we will see. Okay, so fitting So fitting the hierarchical clustering to the data set with n is equal to 5, but I'm not going to directly take 5. So as a first step, from sklearn, okay, dot cluster, okay, it is a cluster method, right? So k means also we have taken from this cluster method, I mean class only, okay, and I'm going to import agglomerative. So a and c should be caps, okay. So agglomerative clustering. Then I'm going to create a model by using the agglomerative clustering. Inside that, I'm going to plus the n cluster. Okay, n clusters. So I'm going to give only three. Okay, then we are having so many parameters, right? Just a minute. Oh, sorry. Just a minute. Okay. So along with this, we are having various parameters also. Okay, what are they? We have to specify the distance, right? What distance method I'm going to use, and then what linkage method you are going to use. So these two parameter we can pass along with this. So to specify the distance, we have to give the parameter as affinity. Okay, affinity is equal to equilibrium distance. Okay, if you are having doubt, sir, how you are saying this is the parameter, how do we find it, means simply you can go for the help method. Okay, in the help method we have to specify, for example, agglomerative clustering means, so try to give that. Okay, I haven't not yet run it, right? Just a minute, I'm just commenting it. I'm running this portion alone. Okay, from sklearn, I have imported the agglomerative method. Now I'm going to the help section. So inside that you can see help on class agglomerative in the model sklearn dot cluster dot underscore agglomerative. So here if you scroll down, means see here whatever parameter I told, along with that extra parameters also will be there. So as a first step, n clusters we have to specify, then affinity. So as I told, we are having an attribute parameter called affinity. So in that you have to specify. See, by default we are having Euclidean distance. So if you are specifying, not specifying also, not a problem. Okay, and we are having a linkage. Linkage is what by default. You can convert it to what average, single, and then complete. Okay, likewise various see linkages there, and then they have given the options also, what option you have to give and what is the default option. So everything they have given automatically. Okay, from this you can find. So now, so affinity I'm just giving like equilibrium, then linkage. So here I'm going to give the linkage as average. Okay, so third method, average linkage method, I'm going to use to find the distance between one point to the other points in the next cluster. Okay, so once after doing this, I have to find the y means. Okay, here not prediction, we can say clustering or means. Means is equal to model dot fit underscore predict. Okay, and then I will pass the data set. Okay, I'm not performing any special operation and all. So directly I'm passing the entire data set into my model for training purpose. Okay, okay. So that also I have done. Now what I have to do? Finally, I have to visualize the cluster. by using the matplotlib method. Okay, this and all same thing if you are using with the k means how we have to use that I have given it here. If you want means you can try it in the practical session. See, using k means finding the optimized k value. Okay, and then train, visualize and all. We using k means, right? That you can perform it here and check, so that you try. Okay, I'm not trying that part. Simple, same copy paste, only data set is going to change. Remaining and all going to be remain the same only. Okay, and that also you can take it as a lab. Okay, using the k means same data set, you are going to find the cluster. So how many cluster you will create, how you will find the best cluster value. Okay, this time I have taken n value as 3 only. Okay, so I'm going to get 3 cluster colors. Okay, so I'm just giving x is equal to, here only actually I'm splitting the data as x. Okay, because in plot we have to specify x and y values, right? So all the x is equal to, I'm specifying it as dataset dot ilog. Okay, in ilog I will take all the rows but not all the columns. I'm going to take third and fourth column around. So why I'm taking only third and fourth column? Because in third only we are having income, fourth only we are having the spent amount. So that's why I'm taking only these two columns. Okay, and then label. So labels I can take it from the model itself. So labels equal to, if I give model dot labels underscore, if I'm giving means whatever the column name, it will be passed as a label to our new variable. Then again in this label I will pass the pd dot data frame. Okay, I'm converting the labels into a data frame. Okay, and I'm passing that value again into the label variable. Okay, understood? This will return the values. Then this value I'm passing it to a pd.dataframe method, and again I'm storing it in the same variable. Okay, now again I have to update the x also. So x is equal to pd dot data frame. So again I'm creating this as a separate data frame. Okay, capital X. So p dot data frame of x, storing it in the same variable x. Now I'm going to concatenate those values. Mm, Otherwise directly I will try to give scattering. So and then let us see. Oh, okay. So I have to give PD, I mean, sorry, DF I have taken, which is a short form of data frame. So in that PD dot concatenate, I am going to concatenate the X value and then the label. Okay. And we know that axis. So if I specify axis equal to 1, then how it is going to concatenate? Can anyone say? If I give PD dot concatenate, okay, so what I'm going to concatenate is x value and then the label value. Like how we have done in the k means, each value we will create a one separate pair list of, like what you have given is, remember, np dot array of list of, like that we have created, right? Same thing we are doing it here also, but in a different way using panda. So I'm concatenating each value x comma labels. If I give means for each x value one label will be there, right? Accordingly it will create, and I have to specify the axis. So axis I'm specifying it as 1. Now then I'm going to rename the column. Okay, if I run this part alone, okay, up to here I'm just running, and then I'm checking my df. So if I check my df means, see, it is coming along with the what index value also coming, annual income came, spent came, and then here it is showing as 0. But here I don't want to show it as 0. Instead I want to give some name to it. Okay, annual income spent, and this is nothing but the label. Okay, one means spent, 0 means not spent, like that. We are going to give some labeling. For that, I'm going to rename my particular column. So if you want to rename any one particular column, see, three methods we have seen still now. I mean, two methods we have seen. Now we are going to see the third method. One is we can use mapping method. Second is we can use the encoding, label encoding method. Now if I want to rename one particular column alone means we can use rename method also. Okay, if I give rename means same kind of syntax. Okay, here it is going to change like columns. Okay, we have to give columns is equal to, then um, curly bracket 0, which is the column name. Okay, old column name, colon, and then the new column name I'm going to give. Okay, so now if I check my df means, see, previously it was 0, now it has been changed to label. Okay, so using this method I have changed it. Then now I'm going to plot. Okay, so for plotting purpose, df dot, same df dot plot scatter we have used, right? Same thing I'm going to use it here. Where I have plotted, here I have plotted, right? Same syntax I'm taking, but for differentiate the clustering colors, I'm going to add one more thing. Mm. So to differentiate the color, okay, I will give C is equal to label. Okay, how many clusters I have created this time? I have created 3 clusters. So it is going to have 3 colors based on the label value, and I can specify the color map also. Okay, if I give color map is equal to set one, like that one color map is there. Various color maps are there. You can, if you are giving means accordingly it will choose the colors. Okay, then remaining things and all basic things. What are the things we can give? Plot. Okay, we can give title to our graph. Okay, I'm giving title as income spent analysis. Okay, by using hierarchical clustering. Okay, then my x-axis is going to be income, and my sorry, not y label is going to be my spent. Finally, I have to use plt dot show. So now let me run this. Okay, what mistake I have done? C argument must be a color and a sequence of colors or sequence of numbers, not label. Why it is saying not label? Whether it is labels. Okay. So what if I don't give this? Okay, it is coming, but okay. Otherwise, I will give directly. I will give the colors. Let me check. Value syntax, yes, correct only. Hmm, where I'm missing the label part. Okay, this part you are saying. No, again I made same. Value or a single numeric RGB should be avoided as well. Please use the color keyword argument or provide it to the. Actually, we are having colors also, right? Okay. What if I give attribute color? See, argument has three elements, which is inconvenient with the x and y with size 20. Okay, somewhere I have made the mistake. Label it is showing as number only. 10. Okay. What if I give 5 itself? Okay, otherwise I will use different method. Um, Instead of giving all the colors in single value, let me comment this. So x, let me take it as dataset.ilog. Okay. So why I'm creating is this time I'm not going to take as a data frame. I'm just going to take it as a value. Okay, so 3 comma 4 dot value. Okay, only the values I'm going to take, and instead of using the pandas method, I'm directly going to use the matplotlib method. So matplotlib method means you have to manually specify each and everything. So that is the only thing. It's okay. So plt dot scatter. Okay, I have changed the number 3 to 5. Okay, otherwise once again I will change it to 3 itself. Okay, because I told I will show it with 3. So here I'm changing to 3 means here also it will be 3. Okay, 3 means 0, 1, 2. Those values only it is going to be there in the label part. Okay, so plt dot scatter, and I'm going to take x, okay, capital X of y means. So we are already found the y means, right? So we will just compare whether y means is equal to 0, then comma 0. This also we have seen in k means, I remember, like 0 0 0 1, 1 0 1 1, like that we have done, remember. K means k means. See, here we have done, right? See, y means equal to 0 comma 0, 0 comma 1. Same thing I'm going to use it here. Since I'm going to use 4 cluster, otherwise simply I can copy paste also this one. Wait, a bit slow, just a minute. I think my system got hang. So same, whatever syntax you have seen in the k means, you are going to copy only that first 3 line, not only if you are copying and pasting it here. Okay, and the title, X label, Y label, show and all is there, right? That you can copy paste from here to this particular cell, and if you are trying means you will get the output. Okay, and if you are changing the cluster to 5 means 5 time you have to give this plt dot scatter x y means is equal to 0. So how you will give 0 0 0 1 for x and y, and then 1 0 1 1 2 0 2 1 3 0 2 1 4 0 4 1, like that for 5 clusters you have to give. So to avoid that only I tried this dataset.plot method, but it was unfortunately not working, but I don't know why. I have to check it again once again. Okay. Otherwise, this method definitely for sure it will work, because in K means also we have used the same method only. Okay. Jasser, even everyone will be connected at that time in the zeroth review. Me, Jai Kodi ma'am will be there, and then other person will be there. Only like in tomorrow class, I will complete the machine learning, Venkana Babu. Okay, then I will start neural network. Okay, which is deep learning concept, next level of decision tree. I mean, data science. Okay, so in the zeroth review only, we will assign you a mentor. Okay, based on the project, we will assign mentors for the projects. Okay, so how many members can be there? Maximum 3 members allowed in one group. Okay, not more than that. So now itself find your team members by messaging and connecting with them. Whether if two-person is having same project idea, then they too can join and do the project. Okay. Okay. If no any queries there means I will wind up the session for today. See you in tomorrow's class. Thank you all.